look at some more big ideas in probability next, and these are the ideas of what we call either independent events and also the idea of what we call mutually exclusive events. So we have some data over here once again. So a bunch of adults are asked, hey, are you married and do you have kids? And so this is what happened. And as always, you should always work on the total. So why don't you go ahead and hit pause and go ahead and work on the totals. All right, so now that you have time to actually do the totals here, just to check in, these should be your totals. This should be 264. On this one, it should be 176. Altogether, that would be 440 people. And then we'd have 330 and 110 as our bottom numbers here. All right, so now that we have our totals, we're good to go here. So let's first look at these ideas of being what we call independent events. So first of all, what is an independent event? It's when one event does not affect the probability of another one happening. For instance, if you were to flip a coin, if you were to flip a coin and get heads, that's not going to affect what's going to happen the next time you flip a coin. You're equally likely as you were before to get a head or a tail. Same thing with rolling a die. If I were to roll a die and get a 5, well, it doesn't really change the chance of what's going to happen the next time I roll the die because each die roll is an independent event. So let's look at these two scenarios here. Kids and being married, are these independent events? So what you want to do is pick one variable or the other. So I'm going to go ahead and I'm going to pick kids. So I'm going to say, what's the chance of somebody having kids altogether here? So of all the people, there are exactly 330 people that have kids. That would be the total right down here. And there's 444 people, or 440 people total. If you go ahead and grab your calculator, 330 divided by 440 is 0.75. And what you want to do is you want to say, hey, does being married impact that chance of having kids? So in other words, what's the chance of having kids given you know the person is married? So let's take a look at that one. So if we did that, we would say, well, how many people are married? Well, married people, the total is 264, so I'm going to write that right here. How many people of those 264 have kids? That would be 198. And lo and behold, if you actually take your calculator right now, take 198 divided by 264, you get 0.75. So what does that mean? It means these are independent events. They're both 75% chance of happening. Whether it's of all people, the chance of having kids is 75%, or just of those people who are married, it still is a 75% chance of having kids. So we would say, yes, these are what we call independent events. And there's another idea, it's called the idea of association. And basically, independence and association are opposites. So if we were to say, yes, these are independent events, we would say they are not associated. Okay, so what about the idea of mutually exclusive? Well, mutually exclusive would be, an example would be, say, in cards, you can't be a king and a queen at the same time. Those are mutually exclusive events. They have nothing to do with each other. Whereas you could be a heart and you could be a 10 at the same time because, as we know, there are cards that are a 10 and a heart. It's the 10 of hearts. So are these mutually exclusive events? All you have to do is look at the both. So if I go to married and have kids, I look at that number. As long as this number is not 0, that means they're not mutually exclusive events. So I'm going to say not mutually exclusive. I'm going to go ahead and abbreviate that with ME just to save some time here. So they're not mutually exclusive. And the reason why is 198 people are married and have kids. So are married and have kids. So that is why they are not mutually exclusive. So let's look at one more example here so you can kind of see it in action one more time. So I'm going to go ahead and reveal this here and go ahead and drag this down a bit here. So there it goes, a little more drag here. So let's take a look at a deck of cards. This time I mixed it up a little bit and I gave you the totals, but not what's inside. So we're talking about a card being an 8 and a card being a face card, or not, as the case may be here. So as we know, how many cards are both 8s and face cards at the exact same time? And the answer is none. So I'm going to go ahead and put 0 right there. How many cards are 8s but not a face card? Well, that's all 4 of them. Likewise, how many cards are face cards but not an 8? Well, that's all 12 of them. And then what would be left here is 36. So these would be neither a face card or an 8. So are these having, are having a face card and having an 8, are these independent events? So this time I'm going to pick the second one. So I'm going to say, what's the chance of getting an 8? Well, that would be exactly 4 ways out of 52 cards. There's 4 8s, there's 52 cards total. But what if I said to you, what if I want to find out the chance of getting an 8 given you knew that it was a face card? So let's narrow it down. How many cards out there are face cards? And as we know, there are exactly 12 of them that are face cards. And of those 12, how many are 8s? Well, if you look here, there are no 8s that are also face cards. So clearly, these two are not the same. 4 out of 52 does not equal 0 out of 12. Those are two totally different chances here. So what we're going to say is, we are going to say that these are not independent events. Okay, and the reason why is as soon as we know it's a face card, it changes the chance of being an 8. Likewise, if they're not independent, we would say yes, they are associated. Okay? And finally, are these events mutually exclusive? So go to the both. I'm looking here at the both, right here in this category right here, and I notice, wow, there's none that are both a face card and an 8. So the answer is yes, they are mutually exclusive. And the reason why is no cards are both an 8 and a face card. So, and face card. So that would be an example of mutually exclusive events. There's no way of getting a card that's both at the same time. All right, so that's our final one here of chapter 7.